Hello and welcome to another video. I'm Vilgot and today I was thinking of starting a new series. So what I'm going to do in this series is build a 16-bit computer in scrap mechanic. It will have a 7-bit address. Really good spelling, I know. So that would be, let's see, 7, that is 128 RAM words with 2 bytes each, so 256 bytes of RAM. I don't really know if I'm actually going to implement this much, but it will have the opportunity to have that much. In the ALU I will have add, addition, subtraction, and, as in logic, XOR, logic, or logic, invert A, shift left and shift right. I will probably be implementing JVP, which is a little fun thing me and Just Another Engineer put together earlier. It will probably need some revision, but yeah, it's really cool. I will have a ROM disk reader because we have other disks, which is like a big concrete slab where we can read from. This is how big, how much memory, let's see if I can find it, this one, this thing can store. And it's double the amount if I'm doing 16-bit, which I am, so yeah. I have a disk reader, but I will probably do a new one because I don't know how good the old one actually works. Yeah, now you probably wonder, how am I going to do the memory in this? I'm going for XOR memory. This is a little example for how you can do that. So we have 3 XOR gates which are connected into each other in a circle. Then it stores something if we send a 1-tick pulse, which we get if we, for example, shoot a button with a spud gun. Then it updates. But if it only updates, we can't set a value to it. So that's why we have this XOR gate here. So it checks if this is on and this is off, it gives an output. If this is off and this is on, it gives an output. So basically, if this is different from this, it gives an output. So now we can see that this is on and this is on, so it's off. And nothing happens when I push the button. But if I turn off this button, we see that this one turns on, and this is an AND gate, so it ANDs this signal with the right signal, and then it goes into all 3 of the XOR gates. So now, 1, we want to set it to 0. When we shoot this, we will see that this turns off and this turns off, because it's 0 and 0 is the same thing. Then for reading, it's really easy. Just put an AND gate, take an output, and put a switch or button below it. So now that one is the output. We can set it. So out, and that is just to select which part of memory we're accessing. Oh, and if you enjoy this, you will probably like Just Another Engineer's series, where he builds a 16-bit computer, but with English that's a little more understandable. I will link his channel in the description. So what we need to do now is compact this to as small of an area as possible, which we can make it 3 times 6, because we actually need an output too, which I forgot to add in. So this we need to compact to as small as possible, and we could in theory do this, right? And then turn these into the XOR gates. Oh, and if you don't know how logic works, which I assume that you do, because otherwise you wouldn't be watching this, but if you don't, you can check out the my logic tutorial, which will also be linked down below. So we can make this an XOR, run this AND gate into all of these, and then take an output from there. So this is this circuit compacted. We can hook it up by doing this. Oh, and here it doesn't really, we don't really need to use the output to actually see what's going on. But when we stack this thing, we won't be able to see the gates below. So I didn't actually hook it up. So now output is off and the data is on. If we turn on the output, we can see that it is on. If we want to turn off the memory cell, we can just turn off this switch, which already is turned off, and then shoot this button to give it a 1 tick pulse. When we're actually doing this in the computer, we will probably do something like this, where we have a 1 tick generators. So now we can just do this. So this gives a 1 tick pulse, connect that up there, turn on that, it writes. So, and we can turn this off, it still contains the value, we can output it. So now I just need to make this 16 times over, which will and then it will probably be vertical like this, because that is a lot easier when I am actually supposed to hook it up. So I'll just make 16 of these and I'll be back. And so there we go, we have a 16-bit register or RAM word. We will use this for both. Now it's just color this in so that we know what to hook up to where. It's basically just for convenience, and you probably don't even hear what I'm saying now, thanks to me painting. So yeah, I'll just color code this thing and I'll be back. So now that I've color coded this thing, I also added in read and write here to not have to connect up all of these 32 things and just connect up one thing. So now we just save this to 16-bit XOR register. Save. So I went ahead and built this concrete platform where the actual computer will be built on. So what we need now is a demultiplexer to pick which register or part of or RAM word we want to read from. So this is a 8-bit demultiplexer. We only need 7 bits. This is enable, we don't need enable, so we can just remove that. Then we need to remove this one, because I made this earlier, and yeah, I'm not really wanting to spend another 5 hours on building a new one of these, just to show how it works on camera. But it's... why did I save this? Yeah, so this is basically just, we have these gates as the input, then we connect those down into these NOR gates, then we AND them together. So all of these, so these are all of the NOR gates ANDed together. The second one is the first bit, and all of and the NOR gates ANDed together, and so on until we have done the whole thing. So if we, for example, put some switches here, we connect them up and it counts. These will need to be OR gates because I will have a address bus on 7 bits, which I learned from just another engineer, which is really smart actually, because then you only need to have it is faster than actually using the data bus to transfer the address, and you can have a bigger address than your data. In this case it will be the opposite way around, but yeah. So now it's just connect each one of these up into 16 into these two to select which one it is. So for the first one it will be this one up to those two. This one isn't welded to this thing yet, but that's the thing, point. I will have 16 OR gates here to act as the address bus. No, the data bus, I mean. So now it's just actually building this thing. Good that I'm having a cold and can't go outside. So I have a lot of spare time. So yeah, I will show how I actually connect these things up, and then before I actually start. So it's take this one, connect it up to that one and that one. I actually need to put down 2 gates here, 2 OR gates, paint them accordingly and connect them up to these two. So these will be the RAM in and RAM out. Now the fun part begins. It's connect this up here, this one back there, this one up here, and this one back down here, and so on until I go insane, or I feel like I have enough RAM. The reason why I'm going for this much RAM is because on other computers the amount of the complexity you can do on the programs is heavily dependent on how much RAM you have. So in this computer you will be able to have 128 instructions, or a 7-bit address. Hopefully I haven't missed one yet, no. So yeah, this will be my life for a while. I'll just connect these last ones up on camera just to show that it actually works. And now I really hope I haven't connected something up wrong, because I may have done an error actually making the RAM. So if I put these, because we don't need to test more than 4 bits really, and then in and out, I think, yeah. So nothing stored in it. If we take like let's say 12, that's not 12, that's 12, and then we write to it, we saw that it's flashed. Now if we turn it on, we see that we have data there, and the data is here. So we have that data stored in there. We can set it to 6 if we want to, and I'll turn this off to show that when I turn this on it will go out on the bus. So yeah, this is how you make RAM. Och där var vi. Shit, wrong language. And there we're done. So yeah, it's like 2-3 weeks later. I have now connected this up. I have like been working on this a total of 3 days. And you may see that all of these are still left. That is because you will be able to use these, but they won't be connected in the first version that I make, which will be this one. So I have connected up half of the amount that I will need in total. And that is probably it for this video. I hope that you enjoyed this and that you will see the next one. Bye, see ya.